I want to introduce Matt Cottam. Matt lives in Providence, Rhode Island, and is the founder and CEO of a company called TellArt, which is an industrial design and service design firm with companies on the client roster as diverse as Nokia and Humana, the healthcare organization, and Otis. In addition to that, he's on the faculty of Rhode Island School of Design out there, and where he teaches amazing skills like sketching and hardware and how to do crazy, beautiful things with switches. And I think you'll all enjoy what he has to say. So without further ado, Matt Cottam. Thanks, Matt.
Thank you, Charles. So as a brief disclaimer, I a lot of times travel with this amazing 70-year-old mentor of mine who's this Polish guru in information design, and he always starts off by saying, I'm here to teach you very important design principles, and Matthew is here to entertain you. And so I don't have any important design principles, but hopefully you'll find it entertaining. So first thing is a survival tactic. I graduated from school after 2 industrial design degrees in 1999, and so you can imagine, after being in school through better part of the 90s, as a freshman I started off with Pine as a email client, and ended with choosing between several color browsers. And it went from doctors having, shoebox-sized cell phones in their cars to everybody having one and students having them. So as an industrial design student in that kind of formative period, I really was lucky to come out with a sense of responsibility about learning how to design with digital media or digital materials and also embrace the traditional craft-based Bauhaus-like education that I'd gotten at this school. So one of the ways that I tried to learn that for myself was I was really interested in furniture. It's a chair that I made when I was a senior. It's leather and bent plywood and all that Eamesy stuff, and we spend a lot of time in craft and shops. And to make something like that, you start with quarter scale models usually. They're little wood, the joints are duct taped or hot glued together or something. But even though the construction methods aren't the same as you would build a full-scale one, if you push down on it, if you blow on it or something, the legs will deflect or it'll fall over in one direction, not another, and tell you something about how the full-scale model is going to behave. You can move quickly through ideas. Even on a full scale, you can take plywood and drywall screws and screw together junk materials really quickly and iterate 7-8 chairs in a night and have people sit in them and give you feedback and sawzall off parts of the backrest and have them sit down again. That way of working is ingrained in me as the only way to work. But when we started working with imagining a cell phone, we had a block of wood that was lacquered up. It looked really sexy. It looked like a cell phone. We were using Photoshop to make fake little screens under, laminate plastic and stuff. But it didn't tell us anything about the behavior. The best we could do is act out scenarios and pretend with each other. So when I started teaching right after school, the first thing we didn't have any real prototyping toolkits that were at a level that were accessible to designers. I created this project called What is a Switch, where students had to just go to the workshops and get scrap materials, just trash stuff, and it was important that it was free and in quantity, like drinking straws and things like that. And then imagine gestural interfaces, how to capture human gesture to close a conceptual circuit. And the important thing is that not only is this analog and before we have to start talking about programming or anything like that, each student's responsible to bring back 50 examples in just from between a Tuesday and a Thursday. And that kind of forcing them to speed through iterations, really you throw away the first 20 and the rest are sometimes brilliant. And this is just one video. There's more on the web that I can turn you on to. I just taught it in Oslo, Norway recently. And every time there's really surprising, really amazing examples that come out of it. And you can see how they move across different materials. The great thing is when you find trash scraps, sometimes you'll find a whole bunch of triangles that are cutoffs from somebody else's project. And so you start by just working with that geometry and that repetition. Or this student invented a gyroscope without knowing it. Those are dowels inside of drinking straws. He had never heard of a gyroscope sensor or an accelerometer before. And didn't have to have any of that friction of working with unfamiliar materials or techniques before he could start to imagine how it would be in his hands. So I'm going to keep going here. Then the next thing that we could do, Charles was just telling me that Silicon Graphics used to be in this building. Well, they used to be in our school too, in the sense that we had a whole SGI lab, and that's where we learned Alias and all that good stuff. But as I was graduating, that hardware had become dated, and we were moving into PCs. We didn't need iRics anymore, and so they took all the computers out and they brought them somewhere to hopefully be recycled, but they left us milk crates full of the SGI keyboards. And so I took them into my class and we took them apart, and inside we took out the microcontrollers and soldered wires onto the column and rows pads, and then we're able to create toolkits for ourselves. So we used Flash, which we already were learning and had installed, and said, take 2 wires, attach them to the hacked keyboard, put it to the metal door, put it to the metal door frame, and then in Flash say if the letter A is up, start the video. If the letter A is down, stop the video. So now we're able to control the physical environment with our gestural what is a switch projects, but using something that didn't require any drivers. It was operating system level events. Now USB, the bottom right here is a wireless USB keyboard. So in 2000, for $30, we were able to create something we could stick inside of a foam mobile model and have 30-something inputs that was wireless across the room. And there was no other way for us to do it in that amount of time. So the next thing we did, we wanted to be able to control actuators. How many people have used something like Arduino or know what I'm talking about? Okay. So there's this really popular do-it-yourself trend now with Make Magazine and Arduino, and there's lots of toolkits out there. It used to be PIC programming or Basic Stamp and things like that in the 90s, a little bit less accessible than it is today. But my company that started right as I started teaching decided we needed to make that easier too. So what we did was, and we wanted to facilitate collaboration between designers and engineers. We didn't want to just take what was good for engineers and lower the bar by dumbing it down, because we had to have the respect of both groups. And so we created something that you can use either Flash or Java, and there's tutorials and really thorough documentation for either environment. And then you can use them with our software that's really just an XML socket server that talks to, over USB, any of this kind of hardware. So any old MIDI instruments, any of this kind of wireless Arduino fidgets, RFID readers, stuff like that. So now our students in literally a couple of days are able to work with sensors and actuators and Flash and tie that to the web and to animation and to video and all these things that they weren't able to do before. And so to give you just an example, this is a 4-day assignment in Sweden, and the assignment was to think about repetitive stress. I'm just going to turn this down a bit, and how people get bad hands, bad eyes, bad backs from sitting and working at computers all day, and think of funny interface interventions that would cause them to have better habits. So it's literally day one, industrial design graduate students, no programming, no electronics experience, and then Monday, Tuesday, Wednesday, they are starting to build. Thursday, we're debugging, and Friday, we're exhibiting, or people are able to come and participate in the ideas. And now I teach 9 weeks out of the year in Umeo, and these students are really special. Here we're using a Make controller by Make Magazine and the people at Making Things in San Francisco. That's Brian Hinch from TellArt. So here's one about needing to drink more water. It's just a simple force sensor stuck under a beer coaster, but it takes over your desktop. You'll see here. If you haven't taken a break in a while, your desktop will actually disappear on you, and you see the backstage of your computer here. And so to get your desktop back so that you can go back to work, you have to ask your neighbor in the office to pull on these handles with you. And if you hold it for 30 seconds, then it stretches your desktop back out with the force. And then this little blender makes you a fruit drink, and the fan comes on to cool you off, and you sit back down. And these are just little DC motors and confetti inside of a plastic water cup, Literally, the first 2 days, they're getting exposed to stuff they've never done before. They build all of this stuff in about 24 hours. And here, using a rubber mouse as a game controller, using a shoe, this is just a hacked keyboard stuck with upholstery foam and a blanket into a chair. Every once in a while, your desktop goes away, and you have to do a lap in the car in order to get your desktop back. And again, this can be plugged into any computer and run connected to an SWF that could be on the web. It just couldn't be less fussy. Is our goal. Using a pedometer to sort photos, using an office chair to navigate a PDF. So it's a little flex sensor stuck to the piston on the bottom of the chair. A couple of force sensors under your butt so you can lean one way or the other to navigate. There's one at the end here. It's almost over. I want to say for you. It's sharing photos with your neighbors. We're really, really firm believers in this philosophy of fake it till you make it. If people build anything that's unnecessary for the demo to communicate the idea, they get demerits. So this one with the 2 photos, as much as we could have spent a day and done this, with a network and just have 2 flash movies talking to each other, we realized, wait a second. We have 2 really long VGA cables and a computer with a dual display card. Why don't we just make a really wide SWF, put these things 30 feet apart, and no one will know the difference? And it's not because we couldn't. It's because we could move on. We could think more about the user experience instead of making it work. So this is a little bit of a digression. Really believe in this hands-on thing. So being from a design school where handcraft, where we still use chisels and mallets to make dovetail joints before they let us use table saws, before they let us use CAD. When I got a project to work with Massachusetts General Hospital and this guy Ryan Bardsley and the Army, actually, through an art school, it was a difficult thing to socialize around, as you can imagine. So kind of untraditional to have the Army come and sponsor a project. But because we were making simulator for training combat medics, and we learned just what a severe situation that is. We took it on, and we did a lot of in-the-field research, and I can't really talk about how exactly some of the solutions work, but the reason why I show you some of these images is just to illustrate how these industrial designers, faced with a relatively high-tech device, had their own approach that's valuable. And so we were taking force sensors and sticking them inside of rubber legs within 2 weeks instead of sitting in EagleCAD and SolidWorks for 3 months before we had our first prototype. We literally just started pouring dragon skin into molds right away. And so I think the results are different too. I mean, parts of the body are made out of hacked camera tripods. We didn't go down and mill every part that we wanted. Although any parts we did need, we would just go down to a Bridgeport and make it ourselves. Here you can see we're just using Telios to do some of the pulse and arterial system controls. These are people from the Army Rangers came and did a lot of testing for us. But really simple but incredibly powerful presentation these guys had never seen in 1 week. Oh, I can just put pressure on the femoral artery and it stops the spurting of blood. And I was using a timeline in Flash with keyframes to make the blood spurt. I mean, it couldn't have been more primitive. But I think that's the good part. The nice thing about designing something like this is you have the perfect model around all the time. So we were casting muscle groups and fat tissue and bones, and we could always kind of feel each other's arms. It was a very touchy-feely class. We cast fellow students and teachers' faces and hands and heads and all that stuff. You can see, I'll just show you one more little bit and then we'll go on. So this project's still going on. It's back at Mass General Hospital, and hopefully it will get manufactured someday. It's still in the research world. But so we cast the hands of the Brown University rowing coach and embedded it with all of our electronics and bones and posable structures, and I can't really say much more about it than that, but you get the general idea. And so what this did for me, the reason why I show you this, besides it having combining the industrial design and the electronics, is it made me realize when I was doing research that I didn't know how to ask good questions. Industrial designers are being told, oh, go be ethnographers or go be anthropologists, and I mean, we can throw those words around. Some of us have taken an ethnography class enough to know that we can kind of fake it or do whatever, but we're not ethnographers, we're not scientists. But worse than that, when I would be making a lung, I was asked, well, go make a lung. And when you get a hole in the chest cavity, you get a sucking chest wound and tension pneumothorax and, this whole cascading series of physiological events. And I didn't know, why should I know that the pleural cavity of your chest is a vacuum and that we don't suck air in through our mouths. We actually just use our chest muscles to pull air in through our mouths, as an example. And so I started studying medicine. And I became an EMT. I started riding on an ambulance and then got really carried away and really fell in love with it and went to 2.5 years of paramedic school and then 1,600 hours of clinical residencies and I still treat patients in a trauma center and emergency department in Rhode Island. I joined the. I didn't want to, become an ambulance worker all the time, although it's a great job. So I found other ways to apply it. I'm on the National Disaster Medical Team for the Department of Health and Human Services and train for deployments to hurricanes and catastrophic events all year. And so we actually do it. These are, yep. And so just as part of that, to give you an idea how extreme it got, and when I decided to kind of look back at what my goals were when I set out in this weird tangent, I did a 48-hour shift and got to deliver 5 babies within 48 hours, and they were all girls. And I left there and I was speechless, and I realized that there was absolutely no other way that I could have learned that. And there's definitely no way that I can communicate that to somebody. And that's the same as some of these experiential lessons that we create in industrial design. It was sobering as a teacher to realize there is a very obvious threshold between what you're able to teach and when you just need to set up a scenario for people to learn things themselves. And so I'm going to breeze through this a little bit, but one of the projects following that I tried to apply that stuff in was we realized through working on the disaster team that hazmat suits for medics really were awful. They are designed for firemen, and firemen are really in charge of these scenes. But the problem with hazardous material scenes is people's airways are the first things to go, and the airway is the most important thing. Without a patent airway, nothing else matters. And so we realized if people are waiting 30 minutes plus, and we looked at a bunch of statistics, to get out of a hazardous material scene through decontamination to definitive care or even to advanced life support care, then what we should do is try to make suits that and training systems for medics so they can get in and at least intubate patients inside the hazardous scene. This is a major cultural problem with the fire departments and with security. It's a training thing, it's a cost thing, but we took it on anyway because we had the luxury of being inside of education. And so I had been starting hundreds of IVs where it was able to act as a dummy, and we, which wasn't hard, we took all the rubber gloves and actually started trying to really do some of these interventions. In the end, to make a long story short, we created a suit that I know works much, much better than the state-of-the-art one, and we're now just kind of dealing with the reality of technology transfer out of a school into industry. May or may not happen, but I hope somebody does. So we made a full-scale model. The major things were, being short, I race sailboats, so I always have these bib pants that you can pull suspenders. And without that, putting on these suits, even a size small, the problem with things that don't fit perfectly is the crotch will be between your knees. And so internally having some bib suspenders based on my sailing pants, no matter how big the pants were, I could at least pull the crotch up to fit, and you'd keep you from, trip hazards. And things like integrating the jacket into the pants, things like the hood being integrated into the jacket, one person can do it using the snap locking wrist. We looked at the psychological benefits of seal assurance, just having the click versus having somebody just duct tape your wrist and hoping that they got every spot, I think was really a benefit for the user. And so this would take a whole history of suits to describe, but we made it so that it was really efficient. You could use it in different level hazards. And so here's just a really quick kind of non-scientific proof of concept. The guy on the left is using the state-of-the-art suit. The guy on the right is using our suit. They have the same amount of experience putting these on. And you'll see these booties are actually like dishwashing glove material, and they're awful. And our boots are actually integrated into the pants. They're overshoes. The guy on the left is having help from somebody using this really expensive duct tape called chem tape to duct tape the seals. So our guy's done at 2 minutes. And you can see how this goes on. Plus, when we watch people using these suits, they're constantly getting tangled in all of these elastic bands, and the wrinkly, soft face shield becomes filled with condensation right away, and you can't see anything. We actually pipe a cool stream of air over the head to keep the screen from condensating, but there you go. So there's our totally unscientific experiment. Here's the doctor just doing some different interventions with the suit on. So then, again, I wanted to find fun ways to apply medicine, so I joined the National Ski Patrol. Speed up here. And then I threw a class about it. I have the luxury of being able to pick topics for the next course, so just in time. And so we looked at mountains, and you go to a larger mountain like Blackcomb, and from the so somebody gets hurt with, let's say, a femur fracture. The bottom, maybe quarter of the mountain or less, depending on the size of the mountain, you can get advanced life support in ambulances. We're talking about where a person can drive to. Anywhere above where you can drive to, and often helicopters aren't possible, you get basic life support. So these are people that aren't trained in anything about defibrillation or airways or anything like that. So if you're stuffed, you're stuffed. And so what we wanted to do is be able to bring advanced life support higher up, because it takes up to 3 hours to get somebody from the summit of Blackcomb to the bottom. This is according to looking at the statistics from their ski patrol and interviewing them directly. And so if anyone who knows anything about emergency medicine knows you have 1 hour. It's the golden hour to keep somebody alive or not. So this needed a solution. We looked at all different kinds of incidents. Here's us actually. We got season passes donated to us and did a lot of skiing during this class, which was really fun. And so we actually did all these mock injuries and brought patients down the hill and timed ourselves and looked at different scenarios where we wanted to have different touch points available to us during the process. And in the end, we ended up with, I think, a pretty nice solution. It heats the drugs, it keeps the batteries warm so the defibrillator lasts longer, it charges while it's being stowed with solar panels, and it has, I think one of the biggest things that we innovated here was thinking about how all the tools and drugs are sorted and how they're grouped into processes on pages that you tear off with Velcro as you go through a process, or how instead of keeping basic life support separate from advanced life support, we came up with new categories like ortho and soft tissue injuries and airway, more in the way that medics are trained. And so lastly, TellArt does a lot of service design and a lot of products that are tied to services, and I'm sure this looks pretty familiar. These are personas going through different software applications, and sometimes they're physical, they're people and buildings and mobile and all different kinds of interconnections between tangible and intangible touch points. So making things visible is very important, just like making things tangible is. And so we actually have watched surgical procedures and reduced the number of screens on a touch screen device that's a surgical instrument by watching how the workflow back and forth between the patient and the device, and how many times you're taking off and putting on gloves, and where the sterile situations are and where just clean situations are. And I think this kind of visualization has been helpful for us. Sometimes we need to tell these stories to a larger audience. We have to make our graphics not just clear but compelling. This is a presentation about 3 months of research that I led this summer about the nursing home of the future. And then back to tangible, this is a project we did for Nokia that they wanted their graphic designers to be able to imagine new mobile interfaces. And rather than having to constantly rely and tax the engineering team, we hacked some HP handhelds. We made it so we used a piece of software called Sidewindow, so the desktop resolution was extended over to the handheld, which is just something you use with your PDA anyway. And that way, they could take flash movies, stuff them off the corner of their display, and have them appear to be running on the handheld. They inherited the touchscreen without us bothering to make a single board computer. I mean, this was delivered in 3 weeks. And we took one of our analog digital converter boards, slapped it to the back, and enabled them to have up to 9 analog sensors and a bunch of PWM outputs to LEDs and motors and vibrating stuff that they could then have a really quick API in Flash for. So they could say, if somebody touches this thing or some event happens in Flash on the screen, now turn on this LED, or if somebody rubs their hand up and down on the side of the device on a linear touch potentiometer or something, change this in the Flash movie on the screen. So they were able to literally make GUIs tied to new physical interface elements many times a day. Here's us actually trying to solder onto the little jacks on the bottom of the handhelds. But so that's just to get started. While they were playing with that, we were working on something that more closely suit their needs. They needed a 16 by 9 touchscreen. This is pre-iPhone. They wanted to experiment, or pre-G-phone iPhone. They wanted to experiment with touch devices. And so, we searched China. We found the displays. We made a single board computer that runs Linux. And then there it is. And so on this now, they can have the flash player and do all the things they could do on that hacked HP handheld. The idea is to work iteratively so that they're always busy. They don't wait for us to do it right the first time or wrong the first time. And then just to show how sometimes things go through many iterations and end up pretty close to the final thing, this is a power supply we designed for Nokia that's the zero power adapter. So it stops drawing power when your phone is charged, unlike the majority of chargers in the world. It's part of a eco initiative that they have called the Homegrown Power Adapter. And so we did all the EagleCAD, like electrical engineering from scratch with this, and now they're being tested in homes. And just to show you some apps tied to buildings, this is a real thing. We faked it first and then we made it work. This is for Otis Elevator, and you can use an iPhone application to actually call elevators in a building. They know where you are in the building, and they come and they tell you which elevator to go to maximize efficiency, and it actually works. I can't tell you how we faked it, although I wish I could, but I promised I wouldn't. But it not faked it, but a couple of electrical engineers and a couple of industrial designers made this actually work in a safe way in about maybe a month and a half. So to some degree, we didn't bother going in and re-engineering their elevator hardware and software. We hijacked it. But it actually works. It's in Connecticut. And here's a quick little video, just some touchscreen stuff. Go through this kind of quickly. Can't talk too much about this stuff. I'll show you just a couple of images. The idea of, we really try to work in web, mobile, and embedded products and services. We really especially like it when we can connect the web to mobile or mobile to embedded, or all three of them together. This is all I can really show, unfortunately, of connecting elevator cars to the web and to people's corporate badges and creating a customized experience when you ride in elevators. And then lastly, I'll just end with a couple of funny ones. We got invited to go to a conference in Amsterdam, huge conference, like 2,000 people, and Amsterdam, pretty lively situation for a conference, and we were asked to create a social RFID experience. So everyone had RFID tags tied to a pretty detailed profile on the web. Where not only where you're from, but what you like, what you don't like, favorite books, a picture of you, all this stuff. So we went to the pharmacy and bought a breathalyzer on our way to the airport. And we hacked the breathalyzer into an Arduino and plugged it into a computer, and then built an installation about social breathalyzing, maybe. So there was a lot of drinking going on at this conference, and you could come up, and we dealt with the hygiene issue even though it was a particle board box that we built the night before. You take one of a bowl of or jar of drinking straws, and you stick it into a hole in the top of a box, and it tells you, okay, blow, and you blow, and it says, okay, we're reading your blood alcohol level, which, I mean, we did by just taking power off of the buzzer that was the beeper on the thing, so we just knew whether it was high or low. We didn't bother trying to get the percentage blood alcohol because it didn't matter. And then it tells you on the screen, okay, you're drunk or you're not drunk, but the surprising funny part is it shows you your picture and it says, you, CHW, are now drunk, and you're among these people who are drunk, and these people are not drunk, and don't take rides home from these people by picture faces. And it was really pretty absurd. And as the week went on, we built this in 4 days. As the week went on, we kept trying to add some functionality to it, some visuals, like a buoy that would float more or sink more depending on how many people were drunk at the conference at that time. And you can see how it works. People really did trick it, too. They figured out that they could I'm going to skip ahead just a bit. They figured out that they could take a swish of alcohol in their mouth and blow right away, and that they push it off the charts. And this would actually write back to your personal profile too. So on the web, it was keeping a log of what your blood alcohol, whether you were drunk or not at different times. So here's a woman using it for the first time. She blows in the straw. She gets impatient. She thinks it's not done. But the hearts are the symbol of the conference. That's why the pink hearts everywhere. So now it says her name, shows her photo, and says, you're not drunk yet. And this is an early one. And we tested some 650 people. It was pretty funny. It was really interesting to try to make something that in 3 days from hacked Chinese electronics that would deal with the abuse of 650 drunk people. And it did. We left it for hours at a time and went and watched talks, and it never broke, which was amazing. And to give you an idea, we didn't have a piece of hose tubing, so I took a VGA cable and cut the ends off it and pulled all the wire out and used that as the hose to go from the straw to the breathalyzer. That kind of working is what I think we're most excited about. So there you go. And then at the end here, there's the chart of people who were drunk and not drunk at one time during the conference, kind of a bar chart of names. And so to wrap it up and to tie all this stuff together, we do a lot of, we figured, well, we want to test new mobile device ideas, and we would love to have multi-touch and all this stuff. What is it going to take for us to make one of these things like we made for Nokia to do that? And we realized, well, why do that? Why don't we just, again, hijack the iPhone, take advantage of its GPS, text messaging, calling, all of its high-resolution video abilities and everything, but be able to attach as many sensors and outputs to it as we want. And so we did it in a couple of different ways, and we've open-sourced all of this stuff because we don't sell it. We get more out of making relationships with people who want to innovate this kind of stuff. So you press on the force sensor, it changes the size of a ball. This is a little wireless board that we created and stuck inside the protective case on the back of the phone that ties to these sensors and then communicates wirelessly to the phone. So you can then, we created a software environment that inside of Dash Code, instead of having to write Objective-C to create an iPhone app, we wanted designers to be able to do it. So we made a piece of software that lets people like me just use JavaScript and CSS to tie these sensors to everything going on in the phone. And then, of course, we had to make it into a breathalyzer right away. So this actually works. You blow in it, and if you blow above the legal limit, it offers to call you a cab in your area code. And our next invention is going to be to black out the names of people you shouldn't be calling, depending on your alcohol level. And the last thing, this is a thing that we just announced this week at eTech and made open source again. It's all on Google Code, and documentation, source code, everything. And it doesn't require a jailbroken phone. You can use it a couple of different ways. But instead of having this wireless backpack on the phone and everything, we decided to make it simpler. We tried to make it simpler. We took the headphone jack. We created a carrier tone. The sound goes out the headphone cable through a resistive sensor like a force sensor, a potentiometer, or a light sensor, comes back to the phone and into the microphone jack. This is just using the 1/8" jack on the top of the phone, and then tie that to the entire interface and accelerometer and GPS and calling and everything else in the phone with our dash code environments. So I've got a couple of the cables with me. It's just so nice to be so non-invasive. So now we're just dealing with how to distribute it and get it out to people, and it's free for non-commercial use, and it's under the GPL, and so that's it. I just do I have a couple more minutes? 10 minutes? Okay, I'll show you one more. To show the power, I think, of sketching in hardware, we got asked by Humana, this really close client of ours, for a couple of years now, to think about childhood obesity. What can we do to fight childhood obesity? And so we went to Radio Shack and bought a pedometer and took it apart, here it is, and put it on our own little project board and hooked it up to our little Arduino thing, and made a quick little flash game. They're in Kentucky, so we made a horse race. And we went down there, and instead of telling the kind of boardroom of vice presidents, we'd like to use wireless pedometers in an online game for kids to, compete against each other running or walking and have this fight obesity, we were able to hand these pedometers, and this is literally the day before and the day after, hand them to people and have them race in the meeting against each other. I think you can see some of it here. I think that the power of getting them laughing like that has really been a good strategy for us. Again, just using Flash and our NADA software, 2 pedometers hacked into an Arduino, and a quick little flash game. Of course, I let the VP win. And then afterwards, they said, great, let's do it. So we went and we worked with the people who made the guts of the Nike Plus pedometer, rather than starting from scratch and making a pedometer ourselves, which didn't make sense at the time. And we created a game in Kentucky. There are 150 kids in 5 schools. We decided the schools should compete against each other, and the kids should compete against each other. So this is weird, but the schools are represented by school buses. The kids are represented by little kid horses on the buses, and they race around the world past major monuments. So when they're going past the Great Wall of China, we worked with the teachers to give them curriculum, little lesson plans about the Great Wall of China, and we're always trying to tie the curriculum into these physical activities. We're hoping to do more and more of that. We're on a version now that is going to handle up to 50,000 users and has this whole social networking, ad hoc, create your own game. I never would, but I could race against Charles. I know he's a marathon runner, so I wouldn't start with that. But, we could create an ad hoc game against each other living on opposite sides of the country, and it would text me and say, Charles just passed you. So I'd go out for a walk at lunchtime and try to pass him again. And so you get game currency, and you can kind of fix up your avatar. So you can buy a mask and snorkel for your horse if you want. And the teachers, depending on how the school is doing, can soup up their bus, so they can put, chrome headers or whatever on the bus. And we did a little unscientific testing with this too. From watching the activity levels of the kids when we ran the game with just the output of how many steps they were taking compared to when we had the online game, the activity level went up a minimum of 200%, which is pretty amazing. And so now we're running this in the UK, and we're going to come back and do a much broader one in the US. We had an award ceremony at the Kentucky Derby. There's a jockey giving away the trophy to the winning school. So we're doing lots more of that stuff. This one, I'm just going to, because I can't pause it, I'm going to turn up the volume here. This project, I can't really, let me do this. This is the last thing, literally I'll show. We taught a class called Service Design last semester, and the thing we really tried to emphasize was using these physical computing tools and filmmaking to fake it till you make it as much as you possibly can, but make as much of an immersive, compelling case for what you're doing as you possibly can. And so here's a student project by Adam Meyer and Molly Rosenberg, and Maya Garau, and I taught this, and this is just a 3-minute video final presentation for a concept that they had. And this student happened to have a tiny bit of JavaScript experience, so he made a couple of little bits, but not any more than what is demonstrated here. So I'll just let you watch this one.
And I'm a student.
I'm Chloe Doyle, and I am a design manager.
And I'm Xavier Doyle. I'm a stockbroker.
Hi, my name is Debbie Thompson, and I'm a homemaker with 2 small boys, ages 6 and 8.
I like eating at home. Obviously, it's a little bit cheaper. It takes a little bit more time, but I think it's worth it in the long run.
We used to be so creative in the kitchen. We used to make all kinds of fun dishes that we really enjoyed. But now with the new diet, we just can't eat those anymore.
My boys are very picky eaters, and they can eat the same thing all day long. I'm getting tired of it.
I do love the option that Foodie gives me to choose between local, organic, budget, or otherwise. I like supporting my local businesses whenever I can, and when I can't do that, Foodie does give me that option.
Foodie is great because it doesn't even feel like we're on a diet anymore. I mean, I feel like we have such great choices that we can eat whatever we want.
Yeah, and it allows us to plan our meals in advance and, just makes our lives a whole lot better.
After a while, Foodie knew my boys' eating habits better than I did.
Foodie is a service design concept that designs a week's worth of meals specifically for the user and then offers to have them delivered. What makes Foodie so compatible with so many different people is the sign-up process. During sign-up, the user would define how many days a week they'd like to cook at home, the average price per meal they'd like to spend, how much time they have to prepare each meal on average, their skill as a cook, and the variety of food that they'd like to have offered. The user can also define dietary restrictions, such as allergies, diets, and lifestyle choices. Foodie takes in all of this information into consideration when designing the meals for the user. In our research, we found that while users may not be very passionate about the types of food they like, they are very passionate about the foods they do not like. Foodie looks for patterns in the foods to try and understand what it is about the foods they don't like. The reasons a user may not like spinach or clams, for instance, may not be due to the taste, but actual texture instead. Foodie looks at these types of things when trying to design the meals. For each day, the user can define how many people will be eating this meal. Foodie then adjusts all the recipes accordingly. Finished with the configuration? Let's see what's for dinner. If the user doesn't like the selections, they can re-choose. If the user likes the meals offered, but doesn't like the days they're offered on, they can move them around to better fit their need. If the user needs to adjust the time or skill for an individual day, that can be done as well. Once the meals are set, the user is presented with a grocery list of items that will be ordered. A total is displayed in the bottom right-hand corner, and the user can select the items they already have. Selecting an item results in an instant reduction in total price, so the user has an instant feedback as to what's going on. The user can also select the type of priority they'd like for their food, including organic, local, premium, or bargain. The price feedback is instant as well. Now that the user is done, they can select checkout and choose a day to have the groceries delivered. Foodie's service doesn't end there.
Make a lot of physical
Along
artifacts.
with the groceries,
So
Foodie
like
also offers a couple special things. Personalized recipe cards and a food report that not only shows you how much each meal costs, but how much each meal costs per person. When the week is through and the user is ready to reorder,
goes through a couple more features here, but you get the idea. We did a workshop about this at eTech this week, and something we're especially excited about and doing with more people is just how do you bring screenwriting and filmmaking together with these kind of low to medium fidelity props through physical computing, making things work just enough to create these kind of compelling envisionments of the future. So. That's it. That's all I have for you, and I appreciate your time, and it's been a great pleasure to come here today to Mountain View, so thank you. I'll gladly take questions if anyone has any.
You'll have to repeat the question.
Okay. Are there any questions? Somebody who's already eaten lunch has give me a question. Well, let me think. Do I have one for myself? Are we hiring?
I have a question from New York. Can you guys hear me?
Yeah.
So I just have sort of a general question. So you work at RISD, which is an art school, but your president is from MIT. And like a lot of these projects are very sort of functional, you know, like it's something you could actually sort of market. Here in New York, we have ITP, which has an art show every year, and like half the stuff is like, you know, totally sort of, you know, wild sort of art stuff, and the other half of the stuff, people are like handing out business cards and like trying to actually sell it. So I just was wondering, like, what you think about, you know, I think from a sort of, from the sort of observer's point of view, it can be very confusing how to sort of digest these various projects that are, some of which are sort of very useful and some of which are meant to be more sort of provocative and, you know, sort of more on the sort of art end of the spectrum. But how do you sort of, what do you think about that sort of tension? And do you think it's okay for it to be like that? Or you know, just you think it's something you should try to like help people with?
Yeah, I think that's actually a really perfect question. I was with Tom Igoe this week, actually. He's down at the eTech conference with us, and we talk about this stuff a lot. And we have an annual conference called Sketching in Hardware, where we come together and really talk about these ideas with educators and people doing this sort of stuff in industry. And I think I agree with you, or I'd say I do think that it's good to have both of those things. At RISD, we have a digital media graduate program, which is within the division of fine arts. So they really have a mission to not have constraints or design constraints or have to worry about users and things like that. They'll use 5 projectors to make a, you know, wearable keyboard or something and not have to deal with any of the kind of limitations that trying to market something or efficiently manufacture something would bring. And I think that's good. I think you see things that are the other day I heard the head of the department get asked the question, how do you stay current? She says, I don't stay current. I have to stay 10 years in the future. And so she's constantly thinking dealing with these really, really far out art ideas. Whereas in our department, I find that the students really get most excited and do their best work when they have the most constraints. When they're told you can only work with wood, you can only have 2 switches, it can only weigh 1 pound, and it has to be done by Thursday and it has to work, they are most creative. They don't feel that as a limitation. They take that as inspiration. So I'm glad that both of those things exist. And it's interesting that Tom, at the ITP program that you mentioned, deals with both of those things in one classroom. Sometimes I have some rogue factions that have to make art, but we have a sign that says no art in the shop. So I hope that answers your question.
Yeah, thank you.
Okay, well, thanks again very much. Good day.